Okay, I'll stop. Well, keep going. I know, I'm crazy. I was just doing a little, getting out some energy here in my room. I get to sit and plan on the computer all day long. I got to get rid of some energy somehow, right? You get to get outside and run. Mr. Taylor won't let me. I have to work all day long. But anyway, we're talking about energy today. I needed to do exercise more. I'm out of breath just from dancing that little bit. What are some forms of energy is our essential question today. That's what we're going to be looking at in science. So we finished Unit 2 yesterday. We're getting into Unit 3. I like what we talked about, engineering and the scientific method. And those are kind of the bases of science. But now we're getting into the cool stuff. So now we're getting into the physical science today, the way things work and what types of energy they are. This is the kind of science that I like the best. I think you'll like it a little bit better too. It's a little bit more interesting than those first 2 units. You might have liked them, and that's good if you did. I hope you did. I hope maybe convince some of you want to be an engineer or work with technology in the future. Well, today we're looking at some forms of energy. So look at this picture. I see lots of types of energy in this picture. Can you name one? What do you think? Look at this white water. Boy, that's a lot of energy in that rushing water, isn't there? Have you ever been on a whitewater raft or been kayaking like this guy? I've been in a whitewater raft one time, and the guide on our raft said, make sure the river's about to get really narrow and come to a spot where there's a big rock up ahead. We have to make sure we don't hit that rock or somebody might get hurt. Well, our raft hit the rock, and guess who got hurt? Me. I was in the front of the raft, and when we went down real fast and hit that rock, I flew out of the raft and turned a flip in the air. Man, it takes a lot of energy to turn big old Mr. Helton to flip in the air. I turned a flip in the air and hit the water, and it sucked me down the river and sucked my shoes off my feet. It was not fun. I thought I was going to drown. Thankfully, there was a raft who'd already got past it, and they rescued me. But I might not be here today if they didn't. So that was scary. There was energy in white water for sure. What about this guy's paddle? He's got to have some energy to move it, doesn't it? He's got to have his energy in his arms to balance the way he's riding in the river, or to turn, or to slow himself down. That takes energy. So lots of energy in this picture. There's energy holding the raft up, isn't there? Well, we're going to talk about, types of energy today. You need to get your science book out and open it to page 103. Can you believe we've already covered 100 pages of science? I can't hardly believe it. But we have 103 in your science book. You'll want to follow along. We'll look at some vocabulary words today through the lesson, and then you'll go and answer some questions for your assignment today. So make sure you're paying attention as we go. What are some forms of energy? Excuse me, my allergies are a little touchy today. They keep making me cough and sneeze. What is energy? All the lights in your house need energy, don't they? I have a light right here so you can see me better. Without energy, I get a little dark, but I can turn it back on and some energy lights me up. And it wouldn't work without energy. The refrigerator, the washing machine use energy. What are some 3 other things in your home that use energy? So we said lights, refrigerator, washing machine. Oh, I bet you have a cell phone. A cell phone uses a battery, energy from a battery. I bet you have a Xbox or something. It uses energy. I bet you have a TV to play it on. It uses energy. There's 3 things. What do you and a car have in common? You both need energy. Gasoline is the car's source of energy. The car won't go anywhere if it runs out of gas. And you'd run out of energy if you didn't what? You've got to eat something to give you energy, don't you? The food we eat gives us energy. Draw lines to match each item on the left with its source of energy. Well, I can't draw lines on my screen, but we can talk about it. What do you think is the rabbit's source of energy? Did we plug in a rabbit? No. Does the sun heat up the rabbit so he gets warm enough to go? Well, little rabbit probably likes the sun, but I think the rabbit gets his energy from eating carrots, don't you? Yes. What about a computer? Does a computer eat a carrot? No. Does he get warmed up by the sun? Not unless it's a solar-powered computer. Most of the time we plug in our computers, and plants get their energy from the sun. Okay, moving on. Making an object move is a change. Energy, let's highlight this, underline this in your book if you have a pencil, or highlight it. Energy is the ability to cause change in matter. Okay, we'll do a very simple illustration of that. Here's a pen. I'm going to change something about it. I took the lid off. Wasn't that fancy? No, but it took some energy to cause that change. I had to have enough energy to pull that cap off and then put it back on. It caused a change. Energy causes a change in matter. So everything that moves has energy. And where does that energy come from? You can see some sources of energy on these 2 pages. What sources of energy have you used today? Well, in yourself, probably by now, you've at least had some breakfast or a bottle of water or maybe some milk or orange juice. It gave you a little bit of energy. I went with Pals this morning. My Pals peachy tea keeps my allergies from acting up too much, but the sugar in it can give me a little bit of energy as I'm teaching online today. What about some other things? I'm using my computer. It used electrical energy. The lights above me, the light here in front of me, all of these are using energy. I'm using my fingers to type and to move the mouse. That uses energy. So we've used all kinds of sources of energy today. Where does this toy get its energy? Well, what kind of toy is that? I can't tell. Either it maybe has batteries, or maybe somebody pushes it and makes it go. Maybe it's one of those kind of cars where you roll it back and it has a spring inside, and when you let it go, it rolls. One of those. This man needs energy to run. Where do you think where he gets it? Runners eat healthful foods such as trail mix, so they'll have plenty of energy. All right, get moving. Have you ever been on a roller coaster? My favorite roller coaster is Blazing Fury at Dollywood. That's my favorite roller coaster. I'm not real big on ones that go upside down anymore. I used to be, but now I get too dizzy. How about you? Do you like upside down roller coasters? My favorite's the Blazing Fury. When roller coaster cars climb a hill, you hear it going up the hill, and then they get to the top. They seem to stop for just a moment, don't they? Then they speed down to the bottom. How does energy make this happen? Well, something in motion, like the girl on the pogo stick, has kinetic energy. She's bouncing, boing, boing, boing. Kinetic energy is the energy of motion. So something at the top of a hill, like a roller coaster car, has potential energy or stored energy. Potential energy is the energy something stores because of its position or condition. So when something's actually moving, it has kinetic energy. Kinetic energy is the energy of movement. Potential energy is like when that roller coaster is sitting on top of the hill and it's just about, gravity's just about to pull it down. It had potential energy because it was up on a hill, just about to come down. It has potential to go down. Mechanical energy is the total potential energy and kinetic energy of an object. So add them together and you get the mechanical energy. We can have a car. It has mechanical energy, doesn't it? It has an engine that creates potential energy for the car to move. And then when it moves, it actually has kinetic energy. So let's look at these examples down here. The objects in the left column have potential energy. Describe the effect that changing the potential energy to kinetic energy will have on each object. So if there's a ball sitting on top of a hill, it has potential energy to do what? It can roll down one side of the hill or the other, right? So if we push it, it's going to change to kinetic energy and roll down the hill. A person stretches a rubber band back. Oh yeah, are you ready? I'm going to shoot you with this. So this is potential energy because I've not let go yet, but if I let go, oh, I missed you. Then it had kinetic energy. So potential, if you think about a rubber band, that's a really good example of potential and kinetic energy. When it's pulled back, that's potential energy. And when I let it go, It's kinetic energy. Potential is the potential to move or have energy. Kinetic is when it's actually moving. Someone gets ready to throw a paper airplane. So you've got your paper airplane that you designed and you've built a prototype and all those words we learned last chapter. So it's got potential energy because you're getting ready, and then whoosh, you let her fly, and then it has kinetic energy. So do you see the difference between potential and kinetic energy? I told you this was a little more interesting. As the roller coaster cars climb to the top of the hill, they're upside down on top of the hill. They gain potential energy. The higher the cars go, the more potential energy they store. As the cars go down a hill, their potential energy or stored energy decreases because it changes to kinetic energy. The roller coaster cars have more kinetic energy when they move faster. At each point along the ride, the mechanical energy of the cars is the sum of their potential and kinetic energies. All right, so when the car's up on top of the hill, it has a high level of potential energy, but then when it starts moving, it has lower potential energy and more what? More kinetic energy. And the total amount of potential energy plus kinetic energy is its mechanical energy, okay? So that's not that hard to understand. Potential, it's about to move, then it changes to kinetic when it moves. Those two added together at any point equals the total mechanical energy. The roller coaster goes fast because of mechanical energy. That's good because a slow roller coaster isn't much fun, unless you're boring like me. The girl pushes the pogo stick spring down. The spring now has potential energy. So when she's squatted down and jumped and that thing is squished down, the spring is squished down, it's got potential energy. But when it springs back up, that was kinetic energy. Flash and boom. You see lightning flash across the sky. Then you hear a boom that's so loud it makes your heart pound. These are two forms of energy. What do you think they are? You see it and then you hear it. You think it's light energy and sound energy? I think that would be it. Light energy is produced and used in different ways. Light is a form of energy that can travel through space. Plants use light from the sun to make food. The same energy from the sun allows us to see. Another source of light energy is electricity. If we couldn't use electricity to produce light energy, it would be difficult to work or play in the evening. So light comes from the sun and light comes from electricity. Okay, so light energy is a type of energy. And then another form of energy is sound. You're hearing sound right now, aren't you? You're hearing my voice. The speakers in your computer are using energy to produce a sound. Energy, the sound energy. Sound is made when something moves back and forth. What do you think's moving back and forth and me making sound? That's weird. I've got vocal cords, don't I? And when we speak, air comes up and goes across those vocal cords and it makes them vibrate. And that's what makes the sound. And some people have big vocal cords and they sing really low. Some people have little vocal cords and they sing really high. That's Mr. Mills, right? But that back and forth motion of your vocal cords called vibration, that's what makes the sound. Have you ever seen a big old speaker like some people put in the back of their car and you hear it and it's vibrating, boom, 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 boom. It's because it's producing sound through vibration. Sound can be described in different ways. For example, pitch describes how high or low a sound is. So high pitch, low pitch. Loud sounds have more energy than quiet sounds. Loud, quiet. The loud one had more energy. Can you think of an example of a loud, high-pitched sound? Gosh, one went by yesterday. It was an ambulance. It was loud and it was high-pitched. Woo, 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 woo. It sounded like that. Loud and high-pitched. So it had a lot of energy, didn't it? Because it was loud and it had a lot of energy because it was high-pitched. Lightning can be hotter than the surface of the sun. Did you know that? It makes the air around it rapidly expand, and that's what causes thunder. So lightning comes, and that heat makes the air expand, and it causes thunder. How far away was that lightning strike? Let's look at this. As soon as you see a flash of lightning, count the seconds until you hear thunder. Then divide the number of seconds by 5. This gives you the approximate distance in miles. So if I heard, and I started counting, 1, 2, 3, 4, and I got all the way to 35, if I divide that by 5, I'll know how many miles away it was. Well, what times 5 is 35? It would be 7. So lightning was 7 miles away. What if I only got up to 20? What times 5 gives me 20? It'd be 4. So it would be only 4 miles away. And 8 times 5 would be 40. So if you counted 40 seconds, it would have been 8 miles away. Do that the next time it storms. You can know how far away the lightning was. Describe the flow of energy as each member of this musical group produces sound. Write your answer in the spaces provided. I don't think I can type on this page, so we'll just talk about it. So here we've got a musical group. Oh man, this dude's playing a saxophone. That's what I play. Did you know I play saxophone? Sometime I'll play it for you on here. He's playing the saxophone. So what are we supposed to do? This flow of energy. What's the flow of energy here? Well, he's producing sound. If you don't know what a saxophone does, it's got a mouthpiece with a little piece of wood on it called a reed. And when you blow into that mouthpiece, it makes the reed go brrr, and that's what makes the sound of a saxophone. Then the shape of it and the buttons you push down. So the vibration of a reed produces the sound in a saxophone. What about drums? I see Lillian Stone. She has drums all the time in our Google Meets behind her. What produces the sound in drums? Well, you take your drumsticks and you hit the drums, and the top of that drum vibrates. And snare drums have a little thing on the outside of them make that little sound that snare drums make. So vibration, when you hit the drums rather, makes the sound. And this girl's playing a violin, or guy, I can't tell, playing a violin. What kind of sound is produced in the violin, or how is the sound produced? Well, you take this bow. I had a girlfriend once who was the first chair violin in the Knoxville Youth Orchestra. She was really good. Can I tell you a story? I shouldn't tell a story in the middle of a science lesson, but I'll tell you a funny story. So her name was Rebecca. And she was my first true love, my first girlfriend. And Rebecca played violin, and so did her sisters. And they got called all the time. She was in high school. Her sisters were in middle school. But they got called all the time to go play at weddings because they were so good. Well, her dad decided that since I was dating his daughter, I should join their group. So he actually bought me like a $2,000 cello and a book to learn to play it. And he said, I bought it for you. You better learn to play it. And so I did. And so I taught myself to play a big cello. It sits up like this, and you play it. Well, long story short, she dumped me. Can you believe it? She dumped me, and I gave the cello back to him. He told me I could keep it, and I should have, because I could have sold it for $2,000 probably. But I gave it back to him because it was the right thing to do. Okay, you didn't need to know all that, but funny story. Okay, so this person is playing a violin. You take the bow, and then there's strings on a violin. It's a lot shorter than a guitar, but it still has the kind of strings similar to what a guitar has. And when you rub that bow back and forth across the strings, it causes the strings to what? It causes them to vibrate. And then there's a little hole in the violin, and it amplifies or makes louder the sound that the string makes when it vibrates. Now this guy has an electrical guitar and a microphone. So this electrical guitar, it's plugged in to an amplifier. And so when he strums his guitar, those vibrations on the electric guitar produce an electrical signal sent to the amplifier, which makes that sound very, very loud. And then since it's electric, you can make it do all kinds of different sound effects. So there's some types of sound energy in this cool band. Energy is all around us. Do you think you could do without energy for one day? Without chemical energy, you couldn't mow the lawn. Without electrical energy, you couldn't power your cell phone. I had to mow this week. Got to mow not quite so often now, but we've got to mow every week, don't we? Chemical energy? Well, what do you put in your gas? Whoops, I said it. What do you put in your lawnmower that's a chemical that makes it go? You got to put gasoline in there, don't you? And of course, electrical energy, plugging your cell phone to charge it. You couldn't power your cell phone. Energy's all around you. Many things use chemical energy and electrical energy. Chemical energy is a form of potential energy that can be released by a chemical change. Chemical energy from food gives us energy. Most cars run on gasoline, a source of chemical energy. Have you ever warmed yourself by a campfire? Fire is the release of a chemical energy. That's odd, isn't it? But fire is a type of chemical energy. Electrical energy provides the energy for most of the devices you use, like computers and television. Electrical energy is a form of kinetic energy that comes from the electric current. Okay, so it's movement, energy that's moving. It's moving in a current. You plug it in your device, and that energy starts moving through the wire. Anything plugged into a wall outlet uses electrical energy. And where does that electricity come from? In most cities, electricity is generated using the chemical energy released during the burning of fossil fuels such as coal and natural gas. The sun and wind can also be used to generate electricity. Have you ever been to Cherokee Dam? Yeah, that produces some of our electricity because when that water goes through the dam, it turns over the turbines inside the dam, and when they turn, they produce a type of electricity. So we've got chemical and electrical energy. This says, identify the things in this scene that use chemical energy and those that use electrical energy. Okay, we can't write in the spaces, but we can type it. So this is a radio, and it looks to me like it's plugged in. Okay, so that's going to be electrical since it's plugged in, right? How about that lawnmower? Okay, well, it's not plugged in. It uses gasoline, which is chemical energy. What else do I see here? We've got the corn, the grill. Chemical energy. What did it say about food, like corn? It says chemical energy from food gives us energy. So the type of energy in food is chemical energy. Our body takes that food and breaks it down into all the different nutrients and chemicals. What else is here? I don't know. Is it that flamingo? I don't know what that sticks for. I can't really tell. Let's see if it tells me. Electrical transformer. I don't know. Anyway, a flaming garden torch. That's what it is. I see that. So fire. I just now saw what that was. Sorry. We saw fire as a type of chemical energy. There we go. I couldn't figure out what it was pointing to. All right. Energy can change forms. Can you read by the light of chemical energy? Can you use electrical energy to make something move? You can do both of these things and more. So have you ever had a glow stick? It's light, isn't it? But it doesn't come from electricity. It comes from the chemicals inside the glow stick. And a car can use electrical energy to make something move. Yeah, there's electric cars. Some people have a new hybrid type of car that you can plug in and it'll go. And I think this is probably like a remote control car that uses electricity to go. Energy can change from one form to another. Electrical energy changes light to light energy when you turn on a light switch. You may also feel the heat energy given off by some light bulbs. Chemical energy in gasoline changes to mechanical energy when the driver presses the gas pedal to drive. Glow sticks have a glass tube inside them. The glass tube has chemicals inside it. When you bend the glow stick, the tube breaks. The chemicals in the tube mix with other chemicals in the glow stick. And when they mix, energy is given off. So chemical turns to light energy. A remote control sends radio waves to the remote control car. Radio waves are another form of energy, similar to light energy. The radio waves change to electrical energy to tell the motor what to do. Start, stop, go faster. The car also has batteries inside it. The batteries change chemical energy to electrical energy to move the car. Inside of batteries are chemicals, and those chemicals produce electricity. That's weird, isn't it? This plant changes light energy from the sun into chemical energy for food. It does that through a process called photosynthesis that we'll study soon. All right, so that was kind of a long lesson. We learned a lot about energy. All right, so I want you to look over this page, summarize what we've learned today. Energy is the ability to cause change in matter. Making an object move is a change. So everything that moves has energy. Kinetic energy is the energy of motion. Potential energy or stored energy is the energy something stores because of its position. The mechanical energy of an object is the sum of its kinetic and potential energy. Light energy enables plants to make food and helps us see. Sound energy is caused by a vibrating object. And energy can change from one form to another. That's a whole lot in one lesson, isn't it? You learned a lot about energy in one day. Okay. You have a little different kind of vocabulary thing here. I want to know forms of energy, and we've got kind of a flow chart or a word web here. Forms of energy, forms of energy. What do you think is going to go right here? I bet it's energy, don't you? And then what are two types of energy? You got kinetic. I don't know which goes where. Potential. I guess this is kinetic right here. Yeah. Try to put these words in the right place. But really what I want you to do is just make sure you know what these 6 words mean, okay? Because I'm going on your quiz today that's for a grade. This isn't for a grade. But on your quiz, you've got to match these 6 words to what they mean. All right? Let's review a little more. Use the words from the box to label each picture. Each term will be used once. Okay? This boy has an up and down motion. He is moving. What kind of energy is the energy of movement? It's kinetic energy, right? You can feel the cello's vibrations. What kind of energy is produced by vibrations? Good, sound energy. Food gives this bird the energy it needs to live. Okay, what kind of energy does food produce? Is produced by food. It's chemical energy, isn't it? The roller coaster cars go to the top of the hill and stop for a moment. And then it has potential energy. You can carry these glow sticks in dark so people can see you. Well, that's light energy. And then a light bulb changes electrical energy into 2 other forms of energy. What are they? Well, let me put my hand right here. One of them, obviously, a light bulb produces light energy. So light energy from electrical energy. But if I get my hand too close, ow! What happened, do you think, when I got too close to the light? It burned because it also produces heat energy. So electrical energy can produce light energy and heat energy. Which of these objects has potential energy? And how do you know? So we've got a bicycle laying down. It's probably just going to lay there, isn't it? We've got a rock just about to fall off a hill. We've got a chair that fell over. We've got a golf ball stuck in the grass. Which one has the potential to move the most? Sure, it's this rock on the side of a hill. It looks like if just some wind came, it'd blow and go down the hill. And then describe how sound energy is produced when you strike the top of a drum. Well, when you strike it, it's going to vibrate, isn't it? And that vibration causes the sound. All right. Many forms of energy all around us and within us. Write 3 paragraphs in the form of an email to a friend or family member describing some ways you use energy in a typical day. Tell your reader where the energy comes and how it transforms into other forms of energy. I tell you what, I won't make you write it today. But if you want to, you can. But you can just talk to mom or dad or brother, sister, grandma, whoever. Say, let me tell you 3 types of energy I use today, and impress them with your vocabulary. You could tell them, if you're sitting there, you can say, I have potential energy because I'm about to go do something. Yeah, impress them with your vocabulary today and tell them about what type of energy you used. Well, that's tomorrow's lesson, so that means we're finished with this one. Please go to your assignment and make sure you got an understanding today of those 6 words that we're back on. this page, because these 6 words, you can find them in your book if you don't remember them, and match them up with the correct definition. That's your assignment today. You can go do it now. See you later.